Hello everyone, this is Dr. Liza and I would like to explain to you a series of videos just to cover on vectors. Why these vectors are important? Because they will be an important fundamental concept for you to solve your Coulomb's law, to solve for electrical force and also um, other variables. Okay, so for that I would like to explain first what is a vector. As I told you before, vector is something that has magnitude, and also direction. Okay, so let's say you have this vector. Okay, before that, vector ni, it depends on what is your axis of reference axis. So usually our reference of axis is, we have x, sorry, let it be black. We have x in this way. If you have something in this direction, this means it is a positive axis, x-axis, positive x-axis. And if you have something in this direction, this represents the y-axis, positive. So if you have something like something goes below here, that is negative y. And if an arrow of vector shows you to the left, that would be your negative x-axis. So this is just like I told you before, this is reference, axis of reference. So let's say you have a number of examples of vectors. Let's say you have this first one. Let's say the vector is this way, and this vector we call it as F2. Sorry, katalah FA. Okay, and then you have another one this way, FB, and this way, this is vector of electrical force FC, and also another one maybe perhaps this way, this is FD. Okay, my question is, what would be the components of this vector FA, FB, FC, and FD? What are the components? Since our reference of axis, we have determined or we have identified it to be positive x and positive y, meaning the components of our vector would be component x, consists of component x, and then the other axis would be component y. So ada dua component, there are two components in order for you to define one vector, any vector. So for example, for this example here, FA, what do you think? Which component exists? Is it component X or component Y? So you can try to redraw back the axis here on top of the main vector that you want to analyze on. For example, like this. So obviously that for FA, we know any vectors in this case of reference axis, any vectors would be an addition of component X and component Y. So in this case, you can see, does FAX exist? No, it does not. because you can see FA, that the vector FA exists only in this component Y. So you can say that FA X is 0 Newton, and the Y component of FA does exist, and the value is FA. So you can see if one of the component exists, so the remainder, I mean, for example, for this one, for FA X 0 kan. So that leaves us with FA equals to FAY. So that's why we have this such equation. So let's try another one. Let's say for example here FB. Okay, FB, try to put there. What do you think about this? So we know any vectors in our definition just now, any vectors is made of two components, x and y. So FB is made of FBX and FBY. We must define them in this direction, x and y. So looking at the direction of the vector, we can see that, okay, there is only one component exists, and that is only in the x component. Y component is 0. So this time, y component goes to 0, and therefore you can directly find your x component is actually equal to the magnitude of the vector itself. So let's say something like this. Okay. Looking at this, you can know that, okay, this time it looks different. Okay, I have to put it like that because the 0 reference is here. So any vector will start from 0 to which direction it goes. Okay. So for this one, this FC, it looks like we have to extend a bit our axis. Okay. So you can see that the vectors that exist are in the negative direction. Okay. So if I can draw the component of FC in different color, so you can see to make this FC, there is component X. There is component X and also component Y. You can draw Y this way, or you can also draw it here. It's the same thing. So for FC, this is FCY, and this other one is FCX. How do you calculate the components? Okay, this time it will be a little bit difficult because you have an angle involved with it. For example, FA just now, the angle, you have to measure it from this X. So in this case, angle is berapa? 90 degree. In this case, angle is 0 because it is on the x-axis itself. So to calculate x and y, you have to use this theta value. Okay, let's say you have the question give you FA, all these vectors, FA equals to 10 Newton. So FAX, just try to calculate first. Okay, let's see whether our calculation is it tally or not tally with our drawing finding just now. So FAX, we know the equation to find any vector in X component in X direction, it is FA the main vector or the fundamental vector, you calculate it, you multiply it with cos theta. And this theta is this theta lah, the one that you measured from x-axis. So if that's the case, then cos theta is how many? Sorry, tan theta is 90. So tan cos 90 is, can you calculate it for me? Cos 90, then you calculate with 10. Cos 90 is 0. So calculate with 10, it is 0. Okay, this tallies with our answer just now here. So you have two options. You can try to draw or you can try to calculate in order to determine the components. Okay, so the next one is to calculate the y component. So you have to know that to calculate any y component, you have to take the main vector FA and you multiply it with sine theta. And this case theta is 90 just now, isn't it? So tan sine 90 is, so sine 90 is 1. So 10 multiplies with 1 gives you 10 Newton. So here you can see that, yeah, your y component is the same as the fundamental vector, the main vector. Kan? Macam ni. So you can see that, okay, to calculate the components, you need to have the angle. And this angle explains to you in which direction the component vector is. Okay, let's try the third one just now. You can try FB on your own. Try to look at FC. So let's say this FC here, I want to use the theta. It is different, okay? You can use the theta only from here to here, but try to remember that in order to get the components full information, I know that you will not understand me at this moment, but try to find theta from this starting point. So you're gonna start calculating your theta from here. So try to go around it, and this is your theta for this FC. So let's say we call it as theta 3 lah, for third example. So in this case, maybe let's say the question gives you this theta 3 as, kalau sini 90, 180, and then maybe another extra 30 degrees here. So 210, isn't it? So let's say theta 3 is 210. 210 meaning from here to here, sorry, where is my pen? So from here to here, it is actually only 30 degree. So theta 3 is 210 degrees. So let's try to calculate what is the vector component in x. FCX sama dengan FC. Okay, let's say FC is 10, the same as just now. So 10 cosine, let us take 210, okay, and try to calculate. So cos 210, it's negative 0.86 times with 10. That gives you negative 8.66 Newton in x direction. Okay. Don't be afraid of this signage, the polarity of this vector, negative. What does it mean? Actually, this tells you that, okay, the magnitude is 8.66, but the direction is in the negative direction of x. So this one, yeah, the vector of FCX is pointing to the negative of x-axis. So how about this FCY? What do you think? When I calculate FC, FCY, mana pen saya ni? When I calculate FCY, what do you think I'm going to get? Positive value or negative value? Yes, definitely I'm going to get negative value because it looks like from my drawing here, FCY pointed downwards. And this means the vector is in the negative of y-axis direction. Let's try to calculate and find out whether that is correct or not. So sine 210. Sine 210 gives you, yes, negative 0.5 times it with 10, you're going to get negative 5. Yeah, in this case also, you get a negative value, meaning this length of FC here, what is the length? The length is 5. What does the negative means? It means that the vector is pointing downward. So when you draw, let's say you don't have this drawing in beforehand, based on this information, you can draw exactly what is the vector. Okay, what do I mean by that? For example, this FCX, it is negative 8.66. So where is negative 8.66? It is in negative. Negative is this way, isn't it? So this is FCX. And also FCY is negative 5. So negative 5 meaning a bit shorter than FCX. So this is FCY. Why shorter? Because this is 5. Your CX is 8.66. So therefore, the resultant vector of FC, when you add those two components up, you're going to get a vector that is in this direction. Okay, this direction. So does it have the same drawing as before? Yes. So bear in mind that when you use your theta correctly, you can define your vectors also correctly lah. So let's say if you use theta not 210 but only 30, you're going to get something else. So try to do that on your own. Okay? Thank you. We're going to move to the next video. See you.